All right, grade 8s. We're going to take a look at a review of our prime factors lesson. So we're going to take a look at what a prime number is, how to break down big numbers into prime factors, and how to find common multiples with the help of common factors and prime factors. So before we do all that, we got to take a look at a couple things. What's the definition of a prime number? So a prime number is a number that only has two whole number factors, and that's 1 and itself. So numbers 2, 3, 5, 7, 11, 83, all of these are prime numbers, okay? Is 1 a prime number? No, it is not. And the reason why is because prime numbers need to be divided by 1 and itself, okay? If it said or itself, then 1 could possibly be a prime number, but it's not, okay? Very important. And just to review what a whole number is, oh, can't pop this bubble. So whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Obviously no decimals, no fractions within there because they're whole. The only difference between whole numbers and natural numbers they don't contain a 0. Okay? So let's take a look at multiples. Sweet. So a multiple is a pretty much, if I'm taking a look at the number 6, my multiples for 6 are 6, 12, 18, 24, 30, 36, etc. So all you're doing is they're pretty much just multiplying another number by a natural number. So 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, etc. This should be review because we've done this in the past. But factors is the opposite. So as you can see, with multiples, we're moving up in the numbers, and that's why you'll hear me sometimes say, we raise the roof when we hear multiples. But when we're talking about factors, we actually break down the numbers into what they could be multiplied in. So for example, if we had the number 12, 6 is a factor, 2 is a factor. So a factor of a number will divide that number evenly without any remainder, okay? It's really, really important for this lesson. So what we're going to do is just to review, when we're thinking of a number, when we're thinking of its multiples, we're moving up. So multiples of a number will always be equivalent to itself or higher than, and factors, we're moving down. We're using division to break down our numbers. So if we take a look at the number 20, my factors are 2, 4, 5, 10, 20. Also, 1 would be a factor. But if I'm looking at multiples, I would have 20, 40, 60, 80, 100, etc. Okay, so that's our quick review on that. But to take a look at how we break down numbers into its factors, the number 8 could be broken down into 2 and 4. Okay? But then we could continue to break it down. Because that 4 right here could be broken down even more. That 4 would be broken down into 2 times 2, and we would still have the original 2. So as you can see, my factors would be 4 and 2, and if I break them down into prime factors, it would be 2, 2, and 2. And if I'm ever asked to put that in exponential form, that would be 2 to the power of 3. Okay? So let's take a look and break down the numbers 24 and 28. I've done this for you. So if we take a look, to break it down into its prime factors, we have 6 times 4 would give you 24. And then we're breaking down 6 and 4 into its prime factors. So 3 times 2 times 2 times 2. And if I was to put that in exponential form, it would be 3 times 2 to the power of 3. Whereas over here, 28, I would break it up into 7 and to 4, and 4 would be broken up into 2 and to 2. Therefore, I would be having 7 times 2 to the power of 2 if they ever asked for the exponential version. Oh, there it is, right here. So my answers are right here in exponential form. Okay, so what you could do is you could pause the video now and try the following, 45 and 64, on your own. And then we could take a look at it, but just make sure to use the same format. And it doesn't really matter which way you break down the numbers. So for example, when I have 24, I could break it up into 6 times 4, but I could have also broken it up into 3 times 8. And what you would have seen is that you would have gotten the same answer. So it really doesn't matter which way you break it down. You will always end up with the same amount of prime factors. Okay, so now how does this help us? In the past, when we've been asked to find the lowest common multiple of two numbers, you know, we would have to pretty much come up with a list of multiples for each number and then find out which one they first had in common. That is super annoying. So something that we would have done in the past would be like to do this. If I had 36 and 45 and I'm looking for the lowest common multiple, I would literally write in every single multiple until I found one in common. Now this one is lucky. I mean, we found this one on the fifth multiple, and here was the fourth multiple. So they're not too painful, but when we're working with bigger numbers and different numbers, it can get a lot worse. So there's actually a strategy that we use when we're looking at this, and we use the lowest common multiples. We use the prime factors to find out which one is the lowest common multiple. So again, you're going to break down both of your numbers into its prime factors. So I have 2, 3, 2, 3, and then over here I have 3, 3, and 5. And what I'm actually going to look for is which ones are in common and which ones are not in common. Okay, so if I take a look, I have 2, a 2, a 3, a 3, a 3, a 3, and a 5. The red represents the 45. The purple represent the 36, and I'm going to just take a look and see which ones I have in common. Well, there's a 3 here. Well, there's 2 3s here and 2 3s here, so they have 2 3s in common. And what I'm going to do is I'm going to combine them. So I can actually cancel both of these out and put them in the common area of my Venn diagram. So I would have 2 3s as factors, 2 2s as factors, and a 5 as a factor. And all I'm going to do is I'm going to multiply them all together. So I'm taking my uncommon, which is my 2 times 2 times my 5, and I'm multiplying by my common factors, 3 and 3. Notice that I don't have to write 4 3s. If there are common factors, you are just combining them into the 2 3s that there would exist in this example. So over here, my answer would be 180 as my lowest common multiple. Alright, and here's a quick review of what we just did. It's really important to note that these 2's right here, they're actually not in common with any 2's over here. And this is where we can kind of get confused sometimes, is if we see 2 factors that are the same, remember, they have to be in common, meaning they have to be factors of the 2 numbers that we are looking at. Alright, and this just basically goes over how we did that. So what you can do is you can try finding the lowest common multiple of 108 and 56, and you can pause the video now, and I will reveal the answer after. And answer revealed, 1,512. So that was our review for section 1.2. Hopefully you guys are masters of prime factorization right now. Okay.